Hi, I'm Sigrid. Hey, Loghman.
Hi. The idea is that if one master go down, you have some extra that can bring the system up again. So it's redundancy.
Okay, so it auto-installs whatever. If something goes down, it can auto-install from something else.
It can recover it. The system can recover itself.
Yeah, okay.
And then you have worker. Then
and what does the worker do here?
Worker is the one who actually you run your pods, your containers, your job, your application, and the workers.
Oh, okay.
Normally you have a lot of workers, depending. But when you start to install a cluster, you start with the basic one, and then you expand.
With more workers.
Or scale out.
Okay, got you. Yeah.
Okay, so in this case we have 3 master and 1 worker, and the idea is that they are connected through a switch, everyone.
Yeah.
And the idea is that we are going to install those 4. We are installing Kubernetes, and we are installing ECCD, Ericsson's Cloud Combined Distribution Environment. So what is that? Ericsson took Kubernetes version, and they put their own stuff, security and this kind of stuff. They called for ECCD or CCD.
Okay.
And this is what we are going to install today.
Okay.
And everything is automated by Ansible scripts. So this is the host. This is the system we have here. We have 4 servers, 3 will be master and 1 worker. And we can see we have a configuration file that we define which one is master, which one is worker. And then when we install our Ansible script, we'll use this configuration file to install the ECCD and then install master separately and then worker as well.
Oh, okay.
So we have this Ericsson release software, ECCD, and simply we just go inside the software that we want to install it and then send the command Ansible playbook install, and we want to print out some more information. And now we are going to install the whole Kubernetes cluster on 4 servers. Sometimes you get some warning or some fail, but normally they are small issue that can be fixed later, but it's not huge. It not affect the cluster.
Okay. So the colors here represent different servers, or
no? The color different
scripts.
Actions. Yeah, this action or scripts happen during the installation.
Okay.
So in this game right now, the blue one is actually doing SSH to the servers.
Okay.
So right now is installing the US specific packages.
Yeah. And yellow is
we can see that here. Yellow is printing out I think it's printing out the YAML file from the, exactly, the config file. So it's printing out the config file.
Okay.
For each server. Deploy Ericube. So right now it's trying to install Ericube, which is the part of the Kubernetes.
Kubernetes, okay.
Yes, so we have Ansible for installation.
Yeah.
We have the Kubernetes open source as a platform. The OS we are using is the Ubuntu 18, is open source as well.
Yep.
Then we are using Python, and of course it will come later when the cluster is up. Then we are going to install Kubeflow, TensorFlow, Jupyter Notebook, this kind of tools as well.
All of this build up in this platform is to create an experimental framework.
Yes.
For running AI applications and big data,
exactly.
Collect big data in real time.
Yes.
And also try out different learning methods, etc., but also to try out the interaction with the teleco network.
That's correct.
So that the network capacity is, sufficient for handling all of this data.
Yes.
Without, right?
Yes, that's correct.
That's
correct. That's the correct. Which is you have simulation, and then you have our test bed.
Yeah.
And then we have a middle level, which is the message queue. In this case, we have EQ, Ericsson queue. And then in the top, we have the ECCD.
Okay, the platform.
The platform. So the idea is that to train the model inside the simulation, because in the simulation, you can explore.
Yeah.
And you can have a different kind of environment. Run different model, different scenario, collect data, send to the ECCD, train the model here, and then when you train the model, then you can apply the model on the testbed.
Yeah.
And because in the testbed you are very limited, you cannot explore as you can do in the simulation.
Okay.
Because in the simulation you can have, for example,
much more UEs. And
you can have thousands of UE, thousands of the unit Bs, while in the testbed we have a 3 cells system with 5, 6 UEs, so you are quite limited here.
Yeah, okay.
But in the simulation you can have, and in simulation you can try different scenario that probably is difficult to do that in the lab. And by training the model, the idea here is that the interface between the simulation and the testbed, these interfaces could be the same. So data that we collect from simulation and data for testbed almost is the same.
It looks the same.
The same.
Okay.
So for the model, it doesn't matter if the data coming from the simulation or from testbed.
Okay. And then in the long run, the idea is that we can use also interface to the real product.
Exactly. So
and it's the same interface.
Yes. So the idea is that by training the model and then applying on the testbed, and then the model can be retrained when you run on the testbed. And probably later you can deploy on the real network in the customer network.
Yeah, that's perfect.
So here inside the ECCD, you can have different tools, platforms, and here we have, for example, we are using Kubeflow. We can use in Kubeflow, we can use in TensorFlow, we can use in, so you have possibility to use different, you can have, for example, Spark, you can have, you can use any tools you want it. Component here, this one, this picture.
Okay.
This is the Kubernetes component. And this is not ECCD, but this is a Kubernetes. So the main platform is Kubernetes.
Yeah.
Probably Ericsson put their own stuff here, some extra
security
things in the system. Otherwise, it's the same principle, exactly the same. Now it's done with the master, and it's now trying to. It's now verified that everything is okay.
Okay.
So, what you see here.
Yeah.
What you see here is that you have different kind of pod. A pod can contain only one container.
Yeah. Okay.
So you have an application.
It's clustering of containers.
Exactly, it's clustering of the containers. So you have possibility to have simple pods or in complex pods.
Yeah. Okay.
Grouping number of containers together. And the node is the servers, the machine that we are running on top of them.
Yeah.
So this is a node. This one is a node, a machine, a hardware. And then from those are mostly workers, those nodes.
Yeah.
And then you have inside that you have different pods, and each pod has their own special application, containers.
Okay.
This is now 85 again. Now it's running.
And now it's all installed.
Exactly. So we can see that we have masters, 3 masters, 1 worker, and then everything's quite well, went well, and then we have Hanov failed.
Yeah.
So, and then now we can check that the cluster is up and running. So we are in the master right now, and then let's see if there is any. Yeah, now we can see. By sending this command, we can see how many nodes are in our cluster, and then we can get service. So you can see there is a Kubernetes services up and running.
Yeah.
So now you can see that this is all the pods running in this cluster, and then this is the command line interface that you can communicate with the Kubernetes cluster. But there is another one which we are using which is much nicer, and this is the Ranger. We are using Ranger for communication with the cluster. So I'm going now to add our cluster to this Kubernetes, to this Ranger. So from here we can monitor, we can manage the cluster.
Okay, so Ranger is like a monitoring device.
Monitor and managing, actually. It's doing it more. So it's pending right now. Now it's trying to collect the information from the cluster, and the interface between the Ranger and the.
Okay, so important.
Yeah, now it's waiting. It's running. How many memory is used right now? Because we are installing, we are not using anything. How many CPU is in used, and now we can control from here direct. And now we can activate other things in the Ranger, and it's the monitoring of the cluster. As you can see here, we don't see any monitoring here of our cluster. And I'm going to activate, so tools, monitoring, and yes, I want to activate these monitoring tools and enable. So, yes, and now we go back to the monitoring, our cluster, and let's see, the monitoring API is not ready. So now it's installing. So what it's doing, now it will create pods in our cluster. So what Ranger now is doing is that it will create pods in our cluster for monitoring the whole ECD cluster. Okay. It's monitoring both nodes, our servers. It will be monitoring every pods running, every application running, every process running, and we can see the memory usage, the storage usage, CPU usage, and this kind of stuff. So when it's ready, we can see those information. You can see those pods and application running here inside.
Okay.
You can go inside directly Grafana.
Yeah.
And then you can look at any node. So now you can see the cluster. Here is now we are looking at everyone. So now I'm interested of only one worker, for example.
Yeah.
I want to see how the worker is behave. Look at the worker, and you can see it's different.
Yeah. I'm also thinking this is a very good DevOps example, because here you have immediately you install, you have all the way, you collect data, and here you have monitoring. So now you are in the operation mode, right?
So you can see the monitoring started for almost 5 minutes ago. So
it's already deployed.
Exactly.
Yeah.